I'm going to combine this, actually. I'll do a couple of examples. One linear, one nonlinear. Nonlinear is coming up in the next section, I believe, anyway. So graphing functions. What's the first way that we learned how to graph a function? We made a, what'd you call it? T-chart? Is that what you called it? Or T-table? That's all we got to do. So let's take this one. F of x is equal to 1/2 x minus 3. So here we're going to have an x and then an f of x column. Because remember, this f of x is just what? Y. So instead of y, I can write f of x. So now, just pick some numbers for x. What do you think would be a good one to pick? 2, why? So I got to multiply it by this half, right? I want the 2's to cancel. So if I pick x as 2, what is f of 2? -2. Everybody okay with that? What if I pick x is 0? F of 0 is what? -3. Let's do another one. F of -2. Not -5, I don't think. -4. Everybody okay so far? Any questions? Now, notice what I've got. A function is a relation. It's just an ordered pair. I've got an ordered pair. A 2 and a -2. A 0 and a -3. A -2 and a -4. So now I can plot this, and we do the same thing. Your x-axis. This is your y-axis, but what is your y? F of x. So here the point, you can, if you want to, on the side of your paper, you can rewrite these as points. 2 and -2, 0 and -3, and -2 for x and -4 for y. Now just plot these points. 1, 2, -2, 0, -3, and then -2, -4. And that's how you plot a function. This is an example of a linear function. Any questions? All this is going to be on your test on Thursday. Okay? We are finishing chapter 2, and this is fair game for your test on Thursday. And I'll assign you some homework for practice. Also, I'll send out an email. I'll be here 1 hour earlier on Thursday. Okay? I'll be here at 5. If you want some individual help or just want to study with some classmates, I'll be here at 5 to kind of facilitate any studying if you have specific questions. I'll send you an email. Let's look at another function, a nonlinear function. Can you remember what was a linear equation? What was the definition of a linear equation? It has a certain form, right? I talked about it. What's that? AX plus BY equals C. That's one idea. It can always be written in that form. What did I talk about? What about the X and the Y? All the exponents are 1, right? That's a linear equation. What do you think a nonlinear is going to have? Probably exponents that aren't 1, right? So in fact, that's exactly right. Let's say f of x is equal to x squared. Now there could be some other nonlinear, but this is a basic one. This is a nonlinear function. The exponent of the x is 2. It is not a 1, so it's not linear. So we do the exact same thing. Let's make a table. What is, if I pick x to be 0, then f of 0 is what? 0 squared, or just 0. What about f of 1? 1 squared, which is just 1. What about 2? F of 2 is 4. Let's do one more. F of 3. Good. Now let's do a few negatives. Negative 1. Not 1/2. So this is negative 1. If I plug negative 1 into the function, so it's just negative 1 and then that's squared. Now what is, I did a problem of the day like this, what is negative 1 quantity squared? Positive 1. What about a negative 2? Positive 4. Any questions on how I got those? I hope you can start to see how a lot of these topics that we're talking about are related. This is just like a problem of the day that we did a while back. If I show you the whole paper, right? Also, these linear functions are a lot like the lines of equations that we did in chapter 2. And you start to see how things are so related. Okay, now how do we graph this? Now we do graph it the same way. What is the point represented by this row? Origin, 0, 0. What is this point? What's my x? 1. What's my y? 1. So it's 1, 1. What about this one? 2, comma. So I'll go over 2. I'm going to go up 4. So go over 2 and up 4. Wow. Okay. So that one's way up there. What about this one? What's the point? 3, 9. So I'll go over 3. I'm going to go up 9. 5, 6, 7, 8, 9. Wow, that's going to be way up here. Somewhere up there, right? What's this point? Negative 1, 1. Negative 2, 4. So we're almost done. This is a function. So one of the characteristics about a function, at least where if it's defined on all real numbers, it should be connected by a line. Anybody know what that shape is called? Parabola. Okay. So this is an example of a nonlinear function. You can use the same technique to graph a nonlinear function. Any questions? All right, let's see what else.